Hey guys, I wanted to go over some problems on the acceleration homework. So this first section here, we're just filling in velocities, and so acceleration changes your velocity, right? So let's look at number 3 here. An object with an initial velocity of negative 25 meters per second. So this means the negative, that means he is going in the negative direction. Right, so if like we have a car, he's going in the negative direction, negative velocity, but his acceleration is positive. So that means he's going to be slowing down at first, right, until he gets to zero. Then he's going to start going in a different direction. So let's see what happens. So every second we're going to add 5. So negative 25 plus 5 is 20. Negative 20 plus 5 is negative 15. Plus 5 is negative 10. Plus 5 is negative 5. Plus 5 is 0. Then we're going to add, right? He still has the same acceleration, but now he slowed down, and then he's going to start going in a positive direction. So he's going to start increasing in speed to the right. So then we have 5 meters per second, 10 meters per second, and so on and so on. So that's how you do these. You're just filling in the numbers. And then this enter the correct sign of the acceleration into this table. You can refer to examples 1 through 4 for help. Okay, let's look at this example. An object with an initial velocity of negative 25. So he's moving in a negative direction. And he is slowing down, right? So that means he has a positive acceleration. So if you're going in the negative direction and you're slowing down, see how he slows down? That's a positive acceleration. Now, if he was speeding up, well, you'll be able to figure it out. So you're just putting positives and negatives in here. Circle this last section here. Circle the correct sign of the acceleration in each of these cases. An object speeding up in the negative direction has a what type of acceleration? An object speeding up in the negative direction. So if this car is going this way, negative velocity, and we want his speed to increase in the negative direction, so then he would have a negative acceleration, right? Because we want it to go this way as well, so that his velocity will increase. That might give you the answer for this one, right? Negative direction and he's speeding up. So we just said the signs have to agree. Let's look at one of these questions. What acceleration? What acceleration? What is acceleration? Okay, let's do number 4. What's given? We got initial velocity is 0. We got a final velocity of 20. We have time 4 seconds. What's unknown? We don't know what acceleration is. What equation are we going to use? Then we're going to substitute. The final velocity is 20. The initial velocity is always where you start. And then his time was 4 seconds. So 20 divided by 4 is 5 meters per second squared, and it is positive. Because he increased in speed, right? Yep, okay. So that was number 4. Let's look at the last page. This is kind of like in the notes where we're looking at a graph. They want you to calculate the slopes of these lines, right? So let's do 3 to 7. Let's do 0 to 1, 1 to 3. I will do 1 to 3, 3 to 7. I'm going to do 7 to 10. I'm going to do from here to here. I'm going to do from 7 to 10 seconds. So I'm going to find the acceleration. So what is the final time, or the final velocity, final velocity is 0 at 10 seconds. At 7 seconds, how fast was it going? 120 minus, because the negative is in the formula, so you got to keep the negative there. And then his final time was 10 seconds. His initial time was 7 seconds. So we got negative 120 divided by 3. That equals a 12 divided by 3 is 4, so minus 40 meters per second squared. That's the acceleration for this part. Yes, so you guys are supposed to figure out the acceleration for these 3, because see, the velocity was going at a different rate, and it changed right there and changed right there. So we're looking at what are these accelerations. And so that's what you're doing here, 1, 2, and 3. And that's about it. This bottom part is kind of self-explanatory. These are directly from the notes. What does it look like on a position versus time, positive acceleration and a negative acceleration? So yeah, just read through the notes, give these a shot. We can, if you have any questions, we can go over them in class.